Hello, my name is Adriana Castillo Hernández, and I'm the first author of the project Validation and Implementation of an Artificial Intelligence System for the identification and classification of biopolymer-producing cyanobacteria. Me and my team at the Escuela Superior de Apan in Hidalgo, Mexico, are working on an easier way to identify microbial genera without compromising the accuracy of the results, utilizing the advances in computer vision and artificial neural networks for this purpose. Given the unstoppable need for plastic nowadays, one major concern is its accumulation on land and water. Common plastic obtained from petroleum is hardly biodegradable, so single-use plastics, containers, packages, and every product made from this kind of polymers is destined to stay for a very long time on landfills or even in nature. Polyhydroxyalkanoates, or PHAs, are a biodegradable and biocompatible alternative to petroleum-based plastics, as their properties are very similar to polypropylene and thus can be used for many products, including prostheses or drug delivery systems. PHAs are produced naturally as a carbon and energy reservoir by microorganisms in conditions of nitrogen or phosphate starvation. When destined for industrial purposes, these biopolymers are produced in bioreactors by genetically engineered bacteria like E. coli or cyanobacteria in axenic cultures. This method of production, however, is economically unfeasible, as the carbon source should be sterilized, and the process is hard to maintain at larger scale. One solution to this problem is using photosynthetic microorganisms like cyanobacteria in septic conditions as mixed cultures or consortia. As this kind of cultures are more adapted to environmental stress, they can thrive in mediums composed of more complex carbon sources or even wastewater from industry and agriculture. However, one important phase of using photosynthetic consortia for PHA production is the characterization of the cultures. To monitor a bioprocess of this nature, it is necessary to identify the microorganisms that make it happen. Microorganism identification and classification has always been an area of interest in biology. Despite this, conventional methods like molecular biology or staining require specialized equipment and are time-consuming. Morphological identification is prone to human error and requires lifelong expertise. Having said this, we believe that current advances in computer vision, image analysis, and artificial neural networks can be useful to overcome this hurdle. In this work, we aim to train a convolutional neural network for the task of identifying the presence of cyanobacteria from the genus Nostoc in light microscope images. To achieve this, a dataset will be created out of microscopy images of a consortium cultured at the Escuela Superior de Apan. The images will be taken at 40x and 100x magnification in different conditions and growth stages. Microorganisms will also be identified through molecular biology and morphologically for labeling and model validation purposes. Once prepared, the image dataset will be processed on MATLAB and data will be split randomly for training and validation of the CNN in a proportion of 80:20 respectively. Obtaining a fast and trustful way to identify microorganisms in a consortium has the potential to facilitate PHA production at larger scales, as a system of this nature can be then adapted to online bioprocess monitoring. We expect this project to be helpful for future experiments and research on cyanobacteria metabolites like PHA, approaching the problems of large-scale bioplastic production in a sustainable, intelligent way, and thus promoting the participation of biotechnology and bioprocess engineering in the advances of Industry 4.0. Thank you for listening and letting me participate as a student in the IMRC 2024. Let me know if you have any questions.